All right, this is called zero product property notes. And again, we are still solving equations that are going to have x squared in them. This doesn't have x squared in it right now, but if you multiplied this out using FOIL, you would get something that looks like this, with an x squared term in it. So this is solving using what's called the zero product property. And the zero product property is pretty easy. Let me flip the paper over. If I have 3 times 0, that is just 0. And if I have 0 times 4, that is just 0. Anything times 0 is 0. So if I have two numbers, a times b, and if I tell you when I multiply them together I get 0, I know that one of these two numbers has to be 0. Okay? I know for sure. One of these two has to be 0. If when I multiply them together, I get 0. Now they both might be 0, but one of them is for sure, okay? Because that's the only way to get 0 when you multiply. So in this problem, you'll notice I'm multiplying x minus 3 times x plus 1, and I'm getting 0. Well, that means either this has to be 0 or this has to be 0. So all we do is think in our heads, what would make x minus 3 be 0? Well, if this x was a 3, it'd be 3 minus 3 is 0, and then 0 times whatever this is would be 0. Now, this side isn't the only one that can be 0. This side could be 0. So I have to think about what would make this side 0. Well, if this x was negative 1 plus 1, that would give me 0. So there's two answers to this. X could be 3, and that would make this 0. And x could be negative 1. That would make this 0. Now, you can get those just by looking at this and saying, all right, I need the opposite of negative 3, is positive 3. And I need the opposite of positive 1, which is negative 1. Another way to do it is just take x minus 3 and set it equal to 0 and solve. I'd add 3 to both sides, it would give me x is 3. Same answer. And I could do the same thing with this side. Take x plus 1 and make it equal 0. Subtract 1 from both sides, you get negative 1. So that's how you would do it algebraically. Many of you will probably just be able to look at this and figure out how to make this 0. If it was 3 minus 3, that would be 0. If this was negative 1 plus 1, this would be 0. So I'm in essence making both of these be 0, or figuring out what would make them 0. Here's another one. So I say, what would make this 0? Well, if x was negative 4. And what would make this side 0? Well, if x was 6, 6 minus 6 would be 0. So a lot of people just think of it as, what is the opposite of positive 4? Negative 4. And what is the opposite of negative 6? Positive 6. Now, you'll notice on this one, it is not factored yet. So I don't have the two things that I'd multiply together to get 0. I have this statement. So you're going to first have to factor this. This is what we did last unit. So remember, x and x goes here. You put 10 on top, you put 7 on the bottom. Think of two numbers that add to be 7, multiply to be 10. It is 5 and 2. 5 times 2 is 10, 5 plus 2 is 7. So the factors are x plus 5, x plus 2. And now you simply figure out what makes each of those 0. Well, x equal to negative 5 would make this 0, and x equal to negative 2 would make that 0. So if they give you one of these, this is called a trinomial because there's 3 terms. If they give you a trinomial like this, you'll have to factor before you can use the zero product property. So x and x, put 20 on top, negative 9 on the bottom. This would be negative 4 and negative 5 because when I add those together I get negative 9, but when I multiply them I get 20. So my factors are x minus 4, x minus 5 equals 0. Now I just use the zero product property. What would make this 0? Well, if x was 4. And what would make this 0? Well, if x was 5. So if I give you the factors already, it's a pretty simple problem. You just figure out what is the opposite of each one. If I give you a trinomial that isn't factored yet, you'll have to factor first using what we learned last chapter, and then figure out your answers.